So this is a temperature humidity sensor, sometimes called DHT sensors. There's like a bunch of different models, blue, white, whatever. They all have different accuracies and all that. But what they do is they look for temperature and humidity and give you those numbers. The way the humidity sensor works, it has two electrodes that put out electricity, and in between them they have this like absorbent material that isn't too resistant to electricity on its own. And when there's water in the air, it gets soaked into this very sensitive, very absorbent, tiny little fabric. And through that, and seeing how much electricity is flowing through and how resistant or how not resistant it is, it's able to give us a value that we can turn into a percentage for humidity in the air. One thing to note is if you're ever getting 0 or 100%, something's probably wrong unless you're underwater or you're in space. The temperature sensing part is called a thermistor, which stands for thermally sensitive resistor, and it's actually super sensitive. What I found with this one is when I was testing it, let's say here on the desk, and then I would take it like to an AC and put it right in front of the AC with cold air coming out, it took a bit of time to adjust to that cold air. It's almost like it was hot and it took time to cool down. Like it started at 23 Celsius and every second it would drop about 0.1, 0.2. And then about a minute or two later, it would get to the actual temperature that was coming out of the AC. The humidity though was accurate the whole time. What you're going to need for this project is your sensor. You're going to need a couple cables. Here I have 3 of them since mine's a 3-pin. If you have a 4-pin or a different model, maybe it's white, not blue, just look for an example on how to wire it up. If you don't have a board on yours and it's just a blue piece, most likely you're going to have to build the board yourself, like put a resistor and do all that. I'll put a picture up on the screen of what that looks like. And if you have one of those, I can always give you a link to a good example that can teach you how to do that. You don't need to have one, but I'm going to use a breadboard just for simplicity. Instead of sticking the cable straight into the sensor, I'm going to stick the sensor in the board, and then from the board wire the cables to the Arduino, which we have right here. We're going to be using the same one as always, an Arduino Uno, and then just a power cable to go to the PC. You got 3 cables. We're going to be using blue for ground, red for power, and brown for signal. Look at our sensor. Let me focus it. We have an S here on the left, so that means the first cable is going to be signal, and then usually it's followed by power and ground. If you're using a sensor, always check which one's which, because it would be really bad if you put power into ground and ground into power. So we're going to plug in our signal cable into the first port, take our red power cable into the second one, and then grab the blue one and put it into the last. Now that we've done this, we have our cables set up. We're going to plug in the blue into ground on the board. There's 2 ports here. We're going to plug in the red into the 5 volt. And then we're going to plug in the signal into digital 2. You can use analog, but for this example and the kind of code we're going to write, we're going to use digital. Once you get all that, just plug it into your computer, open up your Arduino editor, and then we can write some code. Alright, now that you have your editor open, you're going to have to do a couple different things. First, make sure you're on the right board. I have an Arduino Uno, so I chose that one. Make sure you're on the right port, so when you plug in your Arduino and you check your port, usually it'll tell you which one the Arduino is plugged into. And then you're going to have to go to Manage Libraries and download the DHT library. So you just type in DHT, all capitals, and this is the one we're installing right here. It's by Adafruit. DHT sensor library. I'm using 1.3.10, doesn't really matter which one you use. But you have to make sure it's this specific one, or else the commands we're using are not going to be accurate. Once you install that, you're ready to go. Now we have to just declare a couple things. So first we're going to include the library that we just installed, and that's dht.h. Make sure you wrap this in quotes. Then you're going to have to define a couple things. We're going to define the pin we plugged in our sensor to. So we'll call it DHT pin, and we plugged it into port number 2. And then let's define the type of DHT sensor we're using. This is important for some reason. I'm guessing just on how it reads data. So we have to go DHT type, and that's going to be DHT11 according to the library. It has to be written like that with capitals and all that. Next, we're going to actually activate the library, so we're going to tell it DHT, again, DHT, And then in here, we can put the information that we have. So the first thing would be the DHT pin. The next thing will be the DHT type. You don't actually have to declare the variables. You could just put it straight into here, but it's good practice in case you ever need to grab those numbers again. It's also easier. Then in our setup, we're gonna have to do, like always, serial.begin. This activates our console, and then we tell it to run on this frequency, or this band. DHT.begin. DHT.begin is going to activate the sensor, or at least the code that's going to be checking the sensor. And then in here, we could just say started to look for temperature, let's say. Now we can start our loop. First thing we're gonna do is add a delay so that every time it loops, it has to wait, let's make it 2 seconds. There's actually a rated delay for these sensors that says you should be waiting over 2 seconds. 2 seconds is like the lowest you should be going. Some people do 5 seconds, but for the demonstration, I don't want to wait 5 seconds every time I see a number. So we'll put it at 2. Then we gotta capture a couple floats. If you don't know the difference between a float and an integer, floats are decimals. If you still don't understand, I'd recommend maybe looking at data structures a bit. We're going to read humidity. Then we can go and capture the temperature in Celsius. We'll go and capture it in Fahrenheit as well. So all we have to do is call read temperature, and if you put true or you put nothing, that's what tells you if you want Celsius or Fahrenheit. Then all you gotta do is just print all this stuff out. It's good practice to check and make sure that you're not receiving something that isn't a number and all that. So we'll do that quickly. So this is best practice, but what we're doing here is just checking that these are actually numbers and we're not receiving something broken. Because if we are receiving something broken, we want to tell the computer that, or at least tell ourselves that. So we're just going to print here a message letting us know. And then we can say else, and here we can actually print out our temperatures. All right, so what I wrote here is print H, then make it equal to humidity, and then we add a percentage sign at the end. Then we do a bunch of spaces to separate the temperature, which we check for Celsius and for Fahrenheit, and we split those up again with a couple of spaces just to make it all nice on one line. Then all you gotta do is compile it and upload it to your Arduino, and then we should be able to just open up. Looks like we made an error here. Just fix that. Looks like we made another error here. All we gotta do is compile that and upload it. All right, now that it's uploaded, you can go to your tools, serial monitor, or Control-Shift-M. And there we go. We have our temperatures being printed out on the screen. I'll turn on the AC and I'll take this to the AC. I can't show you guys on the camera, but just pay attention on the screen and look at the values and how they change. See how it's dropping every couple seconds, but very slowly. That's what I was talking about earlier, how it takes a couple steps to drop in temperature. It's almost like it's hot right now and it needs to cool down over time. So that's how a temperature humidity sensor works. If you have any questions, any concerns, anything you'd like to see in the future, please do comment below. If this video helped you out, you enjoyed it, anything like that, or you just want to help me support this channel, give it a like and maybe subscribe to the channel if there's anything you'd like to see in the future. Thank you so much everyone for being here, and I'll see you in the next one.